Welcome to our final week, everyone. We have made it to the end of the term. We have just a few items left to do. So let's get started with the week. So last week we looked at carrying capacity of ecosystems, and this is how many individuals of a particular species that an ecosystem can sustain. And when there are too many individuals of that particular species, the death rate will either go up, some of the individuals will immigrate out of the ecosystem. So there is a carrying capacity for ecosystems, how many individuals of a species that the ecosystem can sustain over a particular period of time. This is tremendously important. The Department of Natural Resources in our state, South Carolina, measures the deer population, for example, all over the state, and then they determine how many deer hunters can take in a season, because you don't want the ecosystems to go past the carrying capacity of deer. Deer breed very quickly, they have lots of offspring, and they can be quite damaging to ecosystems because they eat a lot of plant material, and they're big animals. So carrying capacity is an important idea that we need to understand. You also studied cohorts in a population, so you studied how many humans survived in a particular time period, and that's really interesting to look at. You're looking at survivorship. Hester Ford, the oldest American, who is 116 years old this past week, you can imagine that she doesn't have very many people in her cohort. There aren't many people alive in her, say, even in her the decade that she was born in, who are still alive. Hello, everyone. We made it to week 8, the final week of our term. So let's see what we've got going on this week. To recap from last week, you learned about carrying capacity of ecosystems. So ecosystems can sustain a certain number of individuals of different species, and that is the carrying capacity. So we took a look at that with our bird simulation. But this is a very important concept. For example, the South Carolina Department of Natural Resources, DNR, measures the deer population all across our state to determine how many deer can be taken by hunters across the state in order to maintain the carrying capacity of ecosystems, or at least be a little bit under that carrying capacity. The reason for this is because deer are large animals, and they consume a tremendous amount of plant material over their lifetime, and they can actually damage ecosystems if there are too many of them. So carrying capacity of deer in a particular ecosystem is very important. We also studied cohorts of a population, and you did survivorship curves to show you how many individuals in a population survived over a certain period of time. This is important, especially as human beings, because we have longer and longer lifespans, especially in the first world countries. As you can imagine, Hester Ford, who was 116 years old this past week, she's the oldest American person. She doesn't have many people left in her cohort. If you say 110 to 120, there aren't very many people, even in the United States, who have made it to that age. So there are very few people left who were born in the year that she was born in. Okay, this week's topic is all about measuring population size. So I talked about carrying capacity of ecosystems and deer. Well, how do you measure the population size of any kind of organism that you're interested in? We're going to take a look at 3 different techniques in this lab. There are others. There are other techniques besides these, but one is transects. So you just mark straight lines, and then you count every so often, every how many feet, every how many meters, whatever it is that you decide using this straight line technique. So that's a transect. Quadrats are more like a frame, like a square meter frame that you can set down over an area, or it could be even bigger than that or smaller than that. So a quadrat is an area, say 1 meter by 1 meter, and then you count how many individuals it is that you're studying in that particular block. Mark and recapture is also important. You can imagine that this would be more important for animals who move around from one place to another. You can mark them, tag them in some way, and then you count how many you recapture compared to how many have not ever been captured, and this gives you an idea of the population size. So you're going to be looking at 3 different methods for measuring population size. I will tell you that in chapter 45.1, the ecology chapter, they give you some examples for how to answer the questions that you have in this lab. They give you examples of different types of organisms where you would use these different types of population size measuring techniques. A couple of hints. You can use that wax pencil that you've got in your lab kit for the transect activity and just wipe it off with a paper towel. It comes off easily with a paper towel. That's what I did. It worked great. And you're going to need to figure out why you use one counting technique over another, and now we'll refer you back to that chapter 45.1 in the ecology chapter in the OpenStax free textbook. You can find answers there. Okay, and then we've got a few last little items. If you have not finished some work in this term and it's still eligible for being graded, then you need to finish that up and get that turned in this week. The last day to turn in anything period, is this coming Sunday, August the 23rd by midnight, because at midnight, the course is closed to you. And don't ask me to reopen it because I can't. I have no ability to do that. I can't put anything in it. So it is also closed to me except for grading. And I will be grading as quickly as I can these last assignments from week 8. I will also be grading everything from week 7, which is a lot, as you know, because you did all the work. So I'll be doing a tremendous amount of grading this week. And one last thing that I would ask you to do is to fill out your course evaluation. It's been sitting there all term long, but it's ready for you to fill out. Please fill this out for me. My team leader reads these, my dean reads these, and they judge my performance based on these. So please, please, please do this for me. I would greatly appreciate it. And if you have any questions, any issues that have come up, anything that's going on this week that you need help with, you know who I am, Dr. Sigmon. There's my email address, m.sigmon@snhu.edu. Just let me know and I will answer you as quickly as I can. And with that being said, I hope you have a wonderful week. I'll have one last message later on this week that I will send to you. So have a wonderful week and let me know if you need anything.